Ever pondered the journey of data as it zips through a cable? It's a fascinating process, akin to a network of highways, cars, and languages all working in harmony. Let's unpack this journey step by step. Think of brand compatibility as a language barrier. If you only speak English, or in our case Sienna, you'll need a translator or a transceiver that understands and translates this language for you. Now consider the form factor, which is like the size and shape of a light bulb that fits in a specific lamp. In network terms, we call this an SFP, a small form factor pluggable transceiver which fits into a switch. Then comes the operating data rate. Picture this as the speed of data traveling through the cable, similar to how fast you can talk, let's say 10 words per second. The protocol such as Ethernet acts as a common language used by the devices to communicate, ensuring they're all on the same page. The type of fiber used can be likened to a clear single-lane highway. In this analogy, we're using a single-mode fiber, or SMF, for data transmission. The technique of data transmission is like carpooling on the highway. In our case, we use dense wavelength division multiplexing, or DWDM, where multiple data streams travel on the same fiber. The lane count refers to the number of lanes available on the fiber for data traffic. In our example, we have one lane. Channels or wavelengths can be seen as the specific lane and light color used for your data on the highway. Imagine your data traveling on lane 100 GHz CH20 with the light color 1561.42 nanometers. The distance is how far your data can travel on the highway before needing a signal boost, much like how far a car can travel before needing to refuel. In our case, it's 80 kilometers. Power budget is like the fuel efficiency of your data signal, showing how strong it stays over the distance. A higher decibel, or dB, allows for longer distances. The connector is the plug type that connects the transceiver to the cable, akin to a light bulb fitting into a lamp socket. We're using an LC duplex connector, which means two connectors for sending and receiving data. The default temperature is the comfortable temperature range for the transceiver to operate efficiently, much like humans prefer certain temperatures to function optimally. Scene script. Being compliant with SFP MSA specification is like following traffic rules to ensure everything works smoothly on the network. Having a digital diagnostic monitor interface is like having a dashboard that shows how your car is performing on the road. In our case, it's a DOM, or DDM, that monitors the performance of the transceiver. The laser type refers to the type of light source used to transmit data on the fiber. In our example, an externally modulated laser, or EML. Finally, the receiver type is like the detector at the other end that receives the faint light signal and converts it back into data. For us, it's an avalanche photodiode, or APD. So there you have it. The journey of data from one device to another is a complex dance of compatibility, form factors, data rates, protocols, and more. But when simplified, it's a highway of information, zipping along at the speed of light. Fascinating, isn't it?